Okay, this is section 3.2, angles and parallel lines. We got some things that are angling and paralleling. So that's 3.2. I think if I remember to do this right, I'm going to do a discovery activity in class and then have you watch this. So if you were here for the discovery activity, then you can go through these next, like any page that looks like this. So anything that says in green up here, alternate interior, consecutive, corresponding, any of those you can bypass. If you missed class, this is what I want you to watch. Basically, if you have, and then there is more video after this, so let me be clear about that. If two parallel lines are cut by a transversal, so I've got my parallel lines going here, the alternate interior angles are congruent. And basically what we're looking at is this angle right here. We're looking at alternate interior. So this angle, and if it's alternate interior, then I'm going to be comparing this with this angle down here. And it just so happens, and you have to trust me when I do this, that when I make a copy of it, it's the exact same angle. They're equivalent. So this one's right here, and this one will fit perfectly into this spot. Okay? Which, you know, we would do this with a protractor in class, but these angles would be congruent. Okay? It also works the other direction as well. Let's just say you pick this as your alternate interior angle, and then you want to compare it with this. So then if I make a copy, which is exactly the same as the one I have, and I put, let's get that in there just so. Let me flip this around. Isn't this great watching me do this? How interactive is this for you? There you go. Those alternate interior angles are also congruent. So there you go. La-di-da-di-da. They are, in fact, congruent. Alternate exterior angles. Okay? So here's an exterior angle. And if I make a copy of this,
Ethan Noakes, if you're still in the building, please come to the high school office. Ethan Noakes.
Flip this around, fit it in there. It turns out this is the exterior angle, and they are indeed going to be congruent. Okay, and if we do the same thing down here, here's an exterior angle, and I'm going to make a copy of it. Stick this one up here and turn it around. They're going to be congruent. Okay, so alternate exterior angles are congruent. If two parallel lines are cut by a transversal, and once again I'm going to point out you have to have parallel lines to make this work, then corresponding angles are congruent. So I have to look at my corresponding angles. So here is one, and this angle corresponds with this one right here. So they are congruent. I could move, let's see.
Excuse me, Molly Danielson, please call the high school office. Molly Danielson, please call the high school office.
Sorry about that, folks. Listen to that. And it corresponds to this angle over here. Okay. There it goes, fits right in there. So those are corresponding angles, and they are indeed congruent. Moving on, I'm going to do one more just to kind of see. This angle right down here corresponds with this angle right here. Okay, so corresponding angles once again, and there's another set there, but I think we'll get the idea. And consecutive interior angles. They are not congruent. Notice what my green says up there. Consecutive interior angles are supplementary. Let's see what I mean by that. Supplementary means they add up to 180. And I'm going to take this one over here, and I'm going to fit it in there just so. Let's see if I can get that to fit nicely. Oh my gosh, look at that. Okay, now how does that show that they're supplementary? You don't have a protractor. I can get one out, but I'm just going to lay this one right here. And if I'm going to turn it back around now. It's the angle with the red on it, that's why there's a little red dot, so we know exactly which angles we're looking at. If I set those up just so, right next to each other, they form a straight line. Woo! Straight line right there. Oh, Yeah, look at me drawing a straight line. Which means they add up to 180 degrees. So those two angles are supplementary. They add up to 180. All right. Now, this is where we jump in, we take the notes. If you were here for the discovery activity, we're jumping into this. In the figure, the measure of angle 4 is 146. So I'm going to write that in. And we need to find the measure of angle 2. Well, here's angle 2 right here. Well, the good thing to know is that these lines are parallel. And I have a transversal running through them. And the relationship between angle 4 and angle 2 is that they are corresponding. And corresponding angles are always congruent. So the measure of angle 2 is equal to 146. Okay? Example number 2. In the figure, angle 10 is equal to 110 degrees. Find the measure of angle 14. So basically, I have this angle right here. I need to figure out what this one is. Well, what's the relationship between angle 10 and angle 14? They are both alternate interior angles, or it's a pair of alternate interior angles. So they are going to be congruent. So the measure of angle 14 is going to be equal to 110 degrees. Moving on to example 3. In the figure, the measure of angle 4 is 146. Okay? Then we have to find the measure of angle 11. So I'm comparing this to this angle right here. This is a transversal. Oh, these lines are parallel. So all of my parallel rules apply. And these are actually not any kind of correlation. They're not alternate interior or alternate exterior. However, I'm going to be sneaky about this. Angle 4 and angle 6 have a certain relationship. They're called vertical angles. Vertical angles are always congruent. So that means angle 6 is also 146 degrees. Which means angle 6 and angle 11 have to add up to, whatever, I'm going to put angle 11, it's got to add up to 180. It's kind of weird to put a, okay, we're going to say the box because it looks like a number. So I'm going to subtract 180 from 146, and I'm going to get 34. Okay, so basically angle 11 is equal to 34 degrees. Okay, because they are considered to be consecutive interior, angle 6 and angle 11. So they have to add up to 180. Example 4, they tell us that angle A and, line A and line B are parallel. They don't show you in the picture, but they tell you in the write-up. Angle 18 is 42 degrees. Find the measure of angle 25. Okay, so here's angle 25. Here's 18. They are alternate exterior angles. And since they're alternate exterior, they get to be congruent. So the measure of angle 25 is equal to 42 degrees. Example number 5. Now they're going to throw the algebra at you. The measure of angle 5 is 2x minus 10. So I'm going to write that in, 2x minus 10. And the measure of angle 6 is 4, and then y minus 25. And the measure of angle 7 is x plus 15. Find the value of x and find the value of y. Okay, right away I have to look for a relationship between 5 and 7 because this has a y in it and these both have x's. So I better be looking at what I can do with angle 5 and angle 7. It looks to me like angle 5 and 7 are corresponding, and corresponding angles are congruent when the lines are parallel. La 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 la, I have parallel lines. So 2x minus 10 is going to be equal to angle 7, which is x plus 15. I'm going to write this out. Angle 5 is congruent to angle 7. All right, and now I just have to solve. Subtract x from both sides. I get x minus 10 is equal to 15. Add 10 to both sides. I get x is equal to 25. Okay, now I'm going to use that piece of information to try to find y. All right, 5 and 6 are alternate exterior angles, which means they are congruent. So I can set angle 5 congruent to angle 6. Well, let me figure out what angle 5 is. I'm going to put x in. I've got 2 times 25 minus 10, so I have 50 minus 10, which is 40. So this is 40 degrees. That means angle 7 is 40 degrees. And angle 6 must also be 40 degrees because it's congruent to angle 5. All right, well that means this statement is equal to 40 degrees. So basically I just need to solve the math. So I have 4y minus 100. I guess you could do this another way as well. Add 100 to both sides. And now divide both sides by 40. So I'm going to have, is that 35? I better check, otherwise there would be a lot of people asking for extra credit here. 140 divide, I already know it's 35. All right, we're good. All right, this you just need to write down. You need to have it in your notes. It's the perpendicular transversal theorem. Do I need to know that by name? No, you don't need to know that by name. Basically, if you have a line that's perpendicular to one of 2 parallel lines, so if I know I have my parallel lines, okay, and I've got this kind of thing, some kind of a transversal running through, and I can say it's parallel here. So if I see this, then I can go ahead and say, like a conjecture, like, hey, I'm telling you this piece of information. Well, guess what? You can write in this. There's going to be a right angle right there. Okay? Because both of these lines are parallel. I know I didn't write it in there, but they are according to this picture. Okay? So if a transversal runs through and is perpendicular to one of the parallel lines, it's going to be perpendicular to the other. There's just no other way around it. I'm not even going to give you any problems over that because that's pretty much going to be common sense. If we run into it, I will just quickly remind you of this one. Okay? And what does that say? We're done with this lesson 3.2.